Hello everyone, welcome back to my YouTube channel. I, Mr. Yogesh, Faculty of Mathematics, and I am here to put excitement back into the education. In this lecture, we are going to discuss the chapter Trigonometry from paper second, that is Geometry. All questions are from question bank provided by Maharashtra State Board. Look at the first question, 1 mark each question. We have the MCQs. Is of the form cos of theta into sec of theta is equal to. Now look at here, we have given cos of theta into sec of theta. Now we well known sec of theta is the reciprocal of cos of theta, means we can write sec theta to be equals to 1 upon cos theta. So once we replace sec theta by its value, we are getting cos of theta into 1 upon cos of theta. So here cos theta and cos theta from numerator denominator getting cancelled, we are getting the value of cos theta into sec theta, that to be equals to 1. Keep in mind, in case of the trigonometry, once we are finding the value, if there is a tan theta, sec theta, cosec theta and the cot theta, first of all try to convert it in terms of respective sine and cosine value, because sine and the cosine are the souls of your trigonometry. Keep in mind. So we have here correct choice code, the choice code A, that is 1. Look at here the second MCQ, we have to evaluate sec of 60 degree value. So as per the trigonometric table, we have the trigonometric ratios of value at a certain angle, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So we concentrate on the cosine angle value. We have cosine of 0 degree, that is 1, cosine of 30 degree, that is root 3 by 2, cosine of 3, that is 1 upon root 2, cosine of 60 degree, that is half, and cosine of 90 degree, that is 0. Once now we are evaluating the value of secant, the sec theta to be equals to 1 upon cos theta. So let's try to take the reciprocal of respective values at 0 degree, 30 degree, 45, 60 and 90 degree of cosine ratio, so that we are getting the secant ratio values are of the form sec of 0, 1's are reciprocal, we have itself a 1, while root 3 by 2's are reciprocal, we are getting 2 divided by root 3, 1 upon root 2's are reciprocal, we have root 2, 1 upon 2's are reciprocal, we have 2 divided by 1, that means a 2, while 0's are reciprocal, we have reciprocal of 0, that means 1 upon 0, we are getting not defined or infinity, the symbol of infinity which look like 7. Now we have to evaluate here value of sec of 60 degree. So look at the sec 60 degree, we are having a 2. So that sec of 60 degree is equal to, we have a 2. Look at the choice code, we have the correct choice code is choice code B, that is 2. Look at the third MCQ, 1 plus cot square of theta equals to. So is in the trigonometry we have, there are the 3 identities. First identity we have, it is of the form cos square of theta plus sin square of theta, that to be equals to 1. Then next to it we have 1 plus tan square of theta, that is equals to sec square of theta, and the third identity is of the form 1 plus cot square of theta, that is equals to, we have cosec square of theta. So here we have given the third identity, that is 1 plus cot square of theta equals to, we have a cosec square of theta. So among the given choice code C is the correct choice code, that is cosec square of theta. Now look at the fourth MCQ, it is of the form cot of theta into tan of theta is equal to. Now we have to evaluate the value of trigonometric expression, that is tan theta, cot theta into tan theta. We well known cot of theta is the reciprocal of tan theta, that means we can write here cot theta equals to 1 upon tan theta, so that we are getting cot theta means now 1 upon tan theta into tan of theta as it is. So here tan theta and tan theta from numerator denominator getting cancelled, so the value of cot of theta into tan of theta, that to be equals to, we have a 1. So correct choice code is choice code A, that is 1. Or as per I told, once there is a tan, cosec, sec and cot, you may convert it into the respective sine and cos. So we have here the cot theta into tan of theta, that to be equals to. Now we well known cot of theta to be equals to cos of theta upon sine of theta, while tan of theta to be equals to, we have a sine of theta divided by cos of theta. So cot theta we are replacing by its value. we have cos theta upon sin of theta into tan of theta we have sin theta upon cos of theta. So you may try the same proof by using this way also. Here cos theta from numerator denominator getting cancelled and sin theta from numerator denominator getting cancelled. So we might remain with the 1. So that cot of theta into tan of theta, that to be equals to, we have a 1. Now look at the fifth MCQ. We have sec square of theta minus tan square of theta is equal to. So we have to evaluate the value of sec square of theta minus tan square of theta. So now we well known, we have 1 plus tan square of theta as per the trigonometric identity, that is equals to sec square of theta. So let's try to replace this sec square of theta by its value. We have 1 plus tan square of theta and minus of tan square of theta remains as it is. Now tan square of theta with plus sign and with minus sign getting cancelled or gives us a 0. So that the value of sec square of theta minus tan square of theta, that to be equals to, we have a 1. So the correct choice code we have B as a 1. The value of sec square theta minus tan square of theta is equals to, we have a 1. Now look at the sixth MCQ. Sin square of theta plus sin square of 90 minus theta is equal to. So we have to evaluate the value of sin square of theta plus sin square of 90 minus theta. Now we can write this sin square of 90 minus theta as a sin of 90 minus theta the whole cube, the whole square actually. Likewise. Now we well known, as per the complementary angle formula, sin of 90 minus theta becomes, we have a cosine angle of theta. So try to replace sin of 90 minus theta by its value, we have cos theta. So the value of now sin square of theta plus sin square of 90 minus theta, we are getting sin square of theta plus sin of 90 minus theta, we have cos theta and the whole square. Now we can able to write cos of theta the whole square means we are having cos square of theta. And as per the trigonometric identity, we have now sin square of theta plus cos square of theta, that to be equals to, we have a 1. So the value of sin square of theta plus sin square of 90 minus theta is equal to, we have a 1. So the correct choice code is choice code B as a 1. Look at the seventh MCQ. 1 plus cot square of A divided by 1 plus tan square of A is equal to. So that we have to evaluate the value of 1 plus cot square of A divided by 1 plus tan square of A here. So we well known cot of theta be the reciprocal of tan theta, that means cot theta we can write it is of the form 1 upon tan theta. Here angle is A and there is a square, so cot square of theta we have 1 upon tan square of A whole divided by 1 plus tan square of A as it is. Now look at the numerator. Let's by making cross multiplication in case of numerator. 1 into tan square of A, we are getting tan square of A plus 1 divided by tan square of A and whole divided by, we are having 1 plus tan square of A. Now the given rational is of the form A by B whole divided by, we have a C. We can write it is of the form A divided by B into C, where A is nothing but tan square of A plus 1, while B is nothing but we have tan square of A into C is nothing but we have a 1 plus tan square of A. So that here the value of 1 plus cot square of A divided by 1 plus tan square of A, that to be equals to, we have now, we can write tan square of A plus 1 as a 1 plus tan square of A, because addition is always commutative. What is mean by the commutative law? 2 plus 3 is same as that of 3 plus 2. Both are to be equals to, we have a 5. That means we can write tan square of A plus 1 as a 1 plus tan square of A whole divided by tan square of A into, we have 1 plus tan square of A. Now 1 plus tan square of A, 1 plus tan square of A from numerator denominator getting cancelled, we might remain with 1 upon tan square of A. And we well known reciprocal of tan square of A, that means ultimately we have 1 upon tan of A at start, that to be equals to the cot of A. Once there is a square, So that 1 upon tan square of A is equal to, we can able to write now the cot square of A. So the value of 1 plus cot square of A divided by 1 plus tan square of A, that to be equals to, we have cot square of A. Look at the choice codes. We have the correct choice code here. Keep in mind, once we have the angle as a, so that we are getting the cot square of A, not the cot square of theta. So the correct choice code is choice code D as a cot square of A. Look at the MCQ number 8. Sin theta equals to, we have a half, then theta equals to. We have the 4 choice code. Among them we have to choose the correct one. So look at the values of trigonometric ratios at a given angle: 0 degree, 30 degree, 45 degree, then 60 degree, and at last we have the 90 degree. For the sine ratio, sine of 0 degree we have a 0, sine of 30 degree we have a half, sine of 45 degree we have 1 upon root 2, sine of 60 degree we have root 3 by 2, and at the end sine of 90 degree is equal to, we have a 1. So here we have given sine of theta to be equals to half. So look at the sine ratio. We have sine of 30 degree is equal to half. So that we can replace now, like I am writing here, sine of 30 degree equals to half. So we can replace now half by its value as a sine of 30 degree. So sine of theta to be equals to, we have sine of 30 degree. Once there is a sine ratio in case of the LHS, so try to convert this half in terms of the sine ratio. We have a sine of 30 degree is half. So that sine of theta equals to, we have now the sine of 30 degree. Sine trigonometric ratio from both sides getting cancelled. So the value of theta equals to, we have a here 30 degree. Look at the correct choice code. We have the choice code A be the correct, that is 30 degree. Look at the MCQ number 9. We have tan of 90 minus theta is equal to. Look at the triangle. Supposed to be, we are considering a right angle triangle, that is ABC. In it, once we have an angle C equals to theta, so definitely here angle A and C are the complementary angles of each other. So the value of an angle A, we have 90 minus theta. So we have to evaluate at start the value of 90, tan of 90 minus theta. So with respect to 90 minus theta, we have the opposite side is BC, adjacent side we have AB, and the hypotenuse we have AC. So the value of tan of 90 minus theta, that is equals to, we have the basic tangent ratio value, we have the opposite side upon the adjacent side. Opposite side with respect to 90 minus theta is BC, and the adjacent side we have the AB. So tan of 90 minus theta value, we have BC upon AB. Now once we are having angle as a theta, name the 3 sides of a given triangle ABC. With respect to theta, now we have the opposite side is AB, and the adjacent side we have the BC. Once we are evaluating the value of cotangent angle of theta, so that which is equals to, basic formulation for cot ratio we have adjacent side upon the opposite side. Adjacent is with respect to theta is BC, and opposite is with respect to theta AB. So that once the RHS are same, we can equate now the LHS, so that we are having now here tan of 90 minus theta, which is same as that of cot of theta. So the value of tan of 90 minus theta is cot theta. Look at the choice code. We have the correct choice code is C as a cot theta. Look at the MCQ number 10. Cos of 45 degree is equals to. And look at the choice codes too. We have given sin 45 degree, sec 45 degree, cot 45 degree, and tan 45 degree. So now, as per the complementary angle formulae, we are having sin of 90 minus theta, that to be equals to cos of theta. We have given here cos of 45 degree. That's why we are here converting cos in terms of the sine angle. By using the complementary angle formula, we have sin of 90 minus theta equals to cos theta. Here now the theta value is 45 degree. So that we can able to replace now theta by its value as a 45 degree. We can write now the cos of 45 degree, that to be equals to, we have sin of 90 minus 45 degree. So that we are getting here 90 minus 45 is 45. So the value of sin of 45 degree, which is same as that of the cos of 45 degree. That means here we have to evaluate for cos of 45 degree, which is same as that of the sin of 45 degree. So the correct choice code we have choice code A. Cos of 45 degree value we have sin of 45 degree. Look at the MCQ number 11. If sin theta equals to 3 by 5, then cos of theta equals to. Now once we have given here sin theta value is 3 divided by 5 and we have the trigonometric identity is of the form, I am writing we have cos square of theta plus sin square of theta, that to be equals to 1. Try to replace now sin of theta by its value 3 by 5. We have a square. So once we are making square on both sides, sin square of theta value we are getting 3 by 5 the whole square, that to be equals to a 1. Now we well known 3 by 5 the whole square, 3 square is 9, 5 square is 25, that to be equals to 1. To evaluate at start the value of cos square of theta, try to shift now 9 divided by 25 from LHS to RHS. Positive 9 by 25 becomes now the negative 9 divided by 25. So the value of cos square of theta equals to, do the cross multiplication over RHS. We are getting 25 ones are 25 minus of 9 divided by 25. 25 minus 9 we have is 16 divided by 25. So that here we are having now the value of cos square of theta is equals to 16 divided by 25. We have to evaluate the single value of cosine angle of theta. So let's try to take square root on both sides to cancel out the square. Square root of cos square of theta becomes cos of theta, while square root of we are getting 16 divided by 25. Once we separate out the square root of numerator and denominator, square root of 16 is 4, square root of 25 is 5. So the value of cos of theta we are getting at last, that is 4 by 5. Look at the choice code. We have the correct choice code is C, that is 4 upon 5. Look at the MCQ number 12, which is not a correct formula. We have given the trigonometric identities. First identity we have sin square of theta plus cos square of theta, that to be equals to 1, or you may write cos square of theta plus sin square of theta, that is equals to 1, because addition is always commutative. We can change the order of numbers in case of the addition. Now the second identity is of the form we have 1 plus tan square of theta, that to be equals to sec square of theta, and the third identity we have 1 plus cot square of theta, that is equals to cosec square of theta. Look at the choice codes. We have the second identity, that is 1 plus tan square of theta is equals to sec square of theta. So it is correct. Next to it we have the next identity 1 plus cot square of theta is equals to cosec square of theta, and once we shift that cot square of theta from LHS to RHS, so that we are getting 1 is equals to cosec square of theta minus of cot square of theta, so that we can interchange here LHS and RHS and write it is of the form cosec square of theta minus cot square of theta, that is equals to 1. So the third choice code is the correct choice code. Again cos square of theta minus cot square of theta, cosec square of theta minus cot square of theta equals to 1. And at the end we have the first identity sin square of theta plus cos square of theta equals to 1. So that not correct formula we have choice code B, that is 1 plus sec square of theta equals to tan square of theta. Actually we have 1 plus tan square of theta equals to the sec square of theta. So the correct choice code we have here B. Not correct formula we have 1 plus sec square of theta equals to tan square of theta. Look at the next one. If we have given angle A equals to 30 degree, then tan of 2A is equals to. So that here we have given angle A to be equals to 30 degree, and we have to evaluate the value of tan of 2A. Tan of 2 into value of an angle A is 30 degree, that to be equals to we have tan of 30 to the 60 degree. So the value of tan of 2A, which is same as that of tan of 60 degree. Look at the trigonometric ratios of value at a given angle 0, 30, 45, 60 and 90. Among them tan of 60 degree we have root of 3. So the value of tan of 2 now among the given choice code D is the correct choice code, that is root 3. Now let's have a look over question first B. Solve the following question, each of 1 mark questions we are having. Within it the first sub question 1 minus tan square of 45 degree divided by 1 plus tan square of 45 degree is equals to. So that here we have to evaluate the value of 1 minus tan square of 45 degree divided by 1 plus tan square of 45 degree. So that we can write here tan square of 45 degree as a tan of 45 degree the whole square divided by 1 plus now tan square of 45 degree as a tan of 45 degree the whole square. Look at the trigonometric table, that is the value of trigonometric ratios at a given angle 0 degree, 30 degree, 45 degree, then 60 degree and 90 degree. We have tan of 45 degree as per the trigonometric table, that is 1. So let's try to replace each tan of 45 degree by 1. We are getting 1 minus 1 square divided by 1 plus 1 square. Now we well known 1 square is 1, so that we are getting 1 minus 1 divided by 1 plus 1. 1 minus 1 is 0, 1 plus 1 is 2, 0 divided by anything is 0. That means 0 divided by 2, here we have a 0. So the value of 1 minus tan square of 45 degree divided by 1 plus tan square of 45 degree, that is equals to we have a 0. Look at the second question. We have tan of theta equals to 13 divided by 12, then cot of theta is equal to. Now here we have given tan of theta to be equals to a 13 divided by 12 and we have to evaluate the value of cot of theta. So we able to know that cot theta to be equals to reciprocal of tan theta. That means we can write cot theta to be equals to 1 upon tan theta. So that cot of theta to be equals to reciprocal of tan theta value we have 13 divided by 12, whose reciprocal we have 12 divided by 13. That means 1 upon 13 by 12, it is of the form we are having a divided by b by c. We can write it is of the form ac divided by ab, where a is we have a 1 into b is we have a 13 and c is we have a 12. So 12 ones are 12 divided by 30 be the reciprocal of 13 by 12. Reciprocal means we have to interchange the numerator and denominator of the given rational number. So the cot theta value we have 12 by 13 here. Look at the third question. Prove that cosec theta into square root of 1 minus cos square of theta is equal to a 1. So for such a kind of question, whenever we are proving the given trigonometric equation, try to consider the LHS first. We have LHS is of the form cosec of theta into square root of 1 minus cos square of theta. Now we have the trigonometric identity, that is cos of 1 minus cos square of theta here we have. So the trigonometric identity cos square of theta minus plus sin square of theta is equal to 1. Now we require to convert here 1 minus cos square of theta. So shift this cos square of theta from left hand side to right hand side, so that we are getting sin square of theta to be equals to 1 plus cos square of theta, after all shifting, minus of cos square of theta. So the value of 1 minus cos square of theta we have sin square of theta. So let's try to replace the 1 minus cos square of theta by its value we have sin square of theta. So that LHS is of the form now, after all simplifying, cosec of theta into square root of sin square of theta. Now here square and square root cancelled each other, so that the cosec of theta value into we have square root of sin square of theta as a sin of theta. Now we well known cosec of theta be the reciprocal of sin theta, means we can write cosec of theta equals to 1 upon sin theta. So that let's try to replace now cosec theta. We have 1 upon sin theta into sin theta remains as it is. So here sin theta and sin theta from numerator denominator getting cancelled. We are getting the LHS after all simplifying, that is equals to 1, and which is exactly equals to the RHS. Hence we have our proof, that is cosec theta into root of 1 minus cos square of theta, that to be equals to 1, hence proof. Now look at the fourth question. If tan of theta equals to 1, then sin theta into cos theta is equals to. So here we have given tan of theta value is equal to 1. We well known tan of theta we can write as a sin theta upon cos theta, so that we may have now sin of theta divided by cos of theta, that to be equals to a 1. We are replacing tan theta in terms of sin theta upon cos theta. Once we shift the cos theta from LHS to RHS, so that we are getting sin theta is equal to cos theta into 1, we are having now the cos theta. So that we have to evaluate here value of sin theta into cos of theta. So if we able to know here sin theta value is same as that of cos theta, so that we are replacing this sin theta by its value as a cos of theta. So cos of theta into, now we have the cos theta itself, 2 times multiplication, we are getting the cos square of theta here. That means the value of sin theta into cos of theta, that is equals to, we have cos square of theta. Once we have given here tan of theta value is equal to a 1. Or we may have the other proof in terms of the value, that means the real numbered value. Once we have given tan of theta to be equals to 1, we well known tan of 45 degree, that is equals to, we have a 1. So that we can replace this 1 by its value in terms of the tangent angle as a 45 degree. So that we are getting tan theta to be equals to tan of 45 degree. Now tan from both sides getting cancelled, so that the value of theta is equal to, we have 45 degree. Now we have to evaluate the value of sin of theta into cos of theta. Let's replace theta by its value, that is 45 degree. Once we have given tan theta equals to 1, means we have the theta value is 45 degree. So that we are getting sin of 45 degree into cos of 45 degree. Now we well known sin of 45 degree value is 1 upon root 2 and cos of 45 degree value is again 1 upon root 2. So that we are getting 1 into 1 becomes 1, while root 2 into root 2, we have root 2 square, that is 2. So the value of sin of theta into cos of theta we have, that is equals to a 1 upon 2. Now look at the question number 5. It is of the form, if 2 times sin theta equals to 3 times cos theta, then tan theta is equals to. So that here we have given 2 times the sin of theta is equals to 3 times cos theta. So once we shift cos theta from RHS to LHS, multiplier cos theta becomes now the divisor cos theta. So that we are getting 2 times the sin of theta divided by cos of theta, that is equals to 3. Now once we shift here 2 from LHS to RHS, multiplier 2 becomes now the divisor to whom? To 3. So that sin theta upon cos theta we are getting 3 by 2. Now we well known sin theta upon cos theta becomes tan theta. So that tan theta value we are getting here 3 divided by 2. Look at the question number 6. It is of the form, if cot of 90 minus a is equals to 1, then angle A is equals to. So that here we have given cot of 90 minus a, that is equals to a 1. We well known cot of 90 minus theta, that to be equals to tan of theta. So that here theta value is nothing but the a, cot of 90 minus a we are getting tan of a, that is equals to a 1. Now in case of the LHS, once we have the tangent angle, so look at the trigonometric table, we have the value of tan of 45 degree, that to be equals to 1. So that we can replace now 1 in terms of the tangent angle of 45 degree. Now tan and tan from both sides getting cancelled, so value of an angle A is equals to, we are getting a 45 degree. Look at the question number 7. It is of the form, if 1 minus cos square of theta equals to 1 by 4, then theta equals to. We have given here 1 minus cos square of theta equals to 1 by 4. As per the trigonometric identity, we have cos square of theta plus sin square of theta equals to 1. Once we shift the cos square of theta from LHS to RHS, we are getting sin square of theta equals to positive cos square of theta. After all shifting, we have negative cos square of theta. That means the 1 minus cos square of theta is same as that of the sin square of theta. So that here we are getting sin square of theta to be equals to a 1 by 4. Once we take square root on both sides, square root of sin square of theta we have a sin of theta, while square root of we are getting 1 upon 4. Once we separate out the square root of numerator denominator from RHS, square root of 1 is 1, square root of 4 we have a 2. So the sin theta value we have a 1 by 2. look at the LHS, we have there is a sine ratio. So as per the trigonometric table, we have the value of sine of 30 degree that to be equals to a 1 by 2. That means we are replacing 1 by 2 from RHS in terms of the sine angle. So that we are getting sine theta equals to half. Half is nothing but here sine of 30 degree. So sine of theta to be equals to we have 30 degree. Sine from both sides getting cancelled. So the value of an angle theta is equals to we have 30 degree. Now look at the question number 8. It is of the form prove that cos of 90 minus a divided by sin a is equals to sin of 90 minus a divided by cos a. So let us try to consider the LHS. Now we have the LHS is of the form cos of 90 minus a divided by sin of a. Now we well known cos of 90 minus theta as per the complementary angle formulas we are having that is equals to the sin theta. Here theta is nothing but the a. So that after all simplifying the LHS, we are getting cos of 90 minus a is equals to sin of a, and divided by sin of a remains as it is. Now sin a from numerator denominator getting cancelled, so that once we simplify the LHS, we are getting a1, called it as equation number 1. Now try to consider the RHS. RHS is of the form we have sin of 90 minus a divided by cos of a. Now again the same thing, as per the complementary angle formula, we well known sin of 90 minus a to be equals to we have the cos a. So after all simplifying the RHS, we are getting sin of 90 minus a is nothing but the cos a, and divided by we have again a cos a remains as it is. So cos a from numerator denominator getting cancelled, we are getting the RHS is of the form a1, called it as equation number 2. So now from equation 1 and equation 2, we can write the LHS to be equals to we have the RHS. Look at the LHS of the given equation. That means we may have our proof cos of 90 minus a divided by we have a sin a that to be equals to sin of 90 minus a divided by we have a cos a. We are writing at the end, hence we have our proof. Look at the question number 9. It is of the form if tan of theta into a box that is equals to sin theta, then the value of box is equals to. So that we have given here tan of theta into a box that is equals to we have a sin theta. We have to evaluate the value of a box. That means we have to shift at start the tan theta from LHS to RHS. We are getting box to be equals to sin theta upon tan theta. Once we shift the tan theta from LHS to RHS, multiplier becomes the divisor. Now we well known tan of theta to be equals to we have sin theta upon cos of theta. So the value of box we are getting, it is of the form sin of theta divided by we have tan of theta is nothing but the sin theta upon cos of theta. So it is of the form now a divided by b by c. We can write it is of the form a into c divided by b, where a is equals to we have sin theta, b is equals to sin theta, and c to be equals to we have cos theta. So the value of box at last we are getting, it is of the form sin of theta into cos of theta divided by we have a sin theta. Now sin theta and sin theta from numerator denominator getting cancelled. Value of box we are having the cos of theta. That means once we fill up the box by cos of theta, then tan theta into cos theta we are having the sin theta. So the value of box we are having a cos of theta here. Now look at the question number 10. It is of the form sec theta plus tan theta into sec theta minus tan theta is equals to. So that here we have to evaluate the value of sec theta plus tan of theta into sec of theta minus tan of theta. Look at the given brackets that are of the form a plus b into a minus b. So those are the factors of we are having a square minus of b square, where here value of a we have the sec theta, value of b we have the tan theta. So sec theta plus tan theta into sec theta minus tan theta, those are the factors of we can say sec square of theta minus tan square of theta. So now look at the identity. We are having 1 plus tan square of theta, that to be equals to sec square of theta. Once we shift tan square of theta from LHS to RHS, positive tan square of theta becomes now the negative tan square of theta, so that we are getting the value of sec square of theta minus tan square of theta is 1. So the value of, we are writing at the end, sec theta plus tan of theta into sec of theta minus tan of theta, that to be equals to, we have a 1. Hence we have our solution. Look at the next and last question from question 1b, 1 mark each question. Question number 11, sin 75 degree divided by cos of 15 degree is equals to. So that here we have to evaluate the value of sin 75 degree divided by cos of 15 degree. Look at the angles we have given, 75 degree and the 15 degree. Those are complementary angles of each other, because sum of them is, we have the 90 degree. So try to use the formula from complementary angles. Once we are deciding to convert the sine of theta in terms of the cosine theta, then we can able to write here the sine theta in terms of the cos theta by using the complementary angle formula. We are having sine theta to be equals to cos of 90 minus theta. Once we decided to convert the cosine in terms of the sine angle, so that we can able to write here cos of theta to be equals to sine of 90 minus theta as per the complementary angle formula. So here supposed to be, we have to convert the sine in terms of the cosine, so that we are getting sine of, here theta value now we have the 75 degree. So sine of theta to be equals to, we have cos of 90 minus theta value we have 75, whole divided by cos of 15 degree remains as it is. So that to be equals to cos of 90 minus 70, we are getting 90 minus 70 becomes 15. So that cos of 15 degree divided by, we are having cos of 15 degree. Cos of 15 degree, cos of 15 degree from numerator denominator getting cancelled. So the value of sine of 75 degree divided by cos of 15 degree, that to be equals to, we have a 1. You may choose to convert denominator, that is the cosine angle of theta, in terms of the sine theta. So, or we may have here sine of 75 degree divided by cos of 15 degree, that to be equals to, keep that sine of 75 degree as it is and try to convert the cosine angle in terms of the sine angle here. So cos of, here theta value we have 15 degree, so that cos of theta to be equals to, we have sine of 90 minus theta, theta value we have a 15. So that we are getting here sine of 75 degree divided by sine of 90 minus 15 becomes 75 degree. Now sine 75 degree, sine 75 degree from numerator denominator getting cancelled, so that we can able to write again the value of sine of 75 degree divided by cos of 15 degree, that to be equals to, same as that of the previous answer, we are having a 1. So here we are having question first A and first B. Now today we will stop here. During the next lecture we are going to discuss question 2A and 2B from same chapter, that is trigonometry. Thank you.